now let's solve some truss problems here in this video. And they give us truss here, and I have answer here, so we can check. Determine the forcing members FH, GH, and GI. So those are the three members we need to solve. And I'm just looking at it and said, oh, how about I just make one cut, right? Then that we can solve all three. And I think that's the way to go for us to do. So if we cut it, we're gonna get left section or right section, and I decided to use right section. Seems to be, smaller, less stuff going on. But in order to do that, we have to figure out the right section, this external force here, right? So that's our first step. Our first step is go ahead to solve the reaction support at L. So in order to do that, I'm actually gonna erase my cut right here. So go ahead and draw using this FBD number 1. Then FBD number 1, everything here, A is a pin support. We'll have AX and AY. And the L is a roller support, so we'll have LY, right? Basically L. So those are the ones we are solving. But to be honest, I only needed to solve L. I don't need to solve AX and AY because we already figured out using right section, only need L. So to solve L, what can we do in one step? We can just do moment equation. So from FBD number 1, we do moment at A. Then AX, AY will not show up the equation. The only thing will be L in the equation. So in that situation, let's go ahead and see. We have this 5 kilonewton, the first 5 kilonewton. Let me use black. All right, so 5 kilonewton then times this moment of arm. This is 6 panels, 5 meters each, so times 5. That's going to be clockwise rotation, a negative. Then we have the second 5 kilonewton. Then we are going to times moment of arm rotating about A. That's basically 2 panels, so it's 5 times 2 here. It's also clockwise rotation. Then we look at the force at G here, 5 kilonewton, and the moment of arm is going to be 3 panels, 3 times 5, and a clockwise rotation, right? Then same way, what do we have? We have force at B as 1 newton. 1 kilonewton, and 1 kilonewton, the moment of arm is also just 5 meters. And then the 1 kilonewton at D, the moment of arm is 5 times 2, clockwise. And the force at F, 1 kilonewton, is 5 times 3, and it's clockwise rotation. And then we're going to continue to look at the 1 kilonewton at H. So it's 1 times 4 panels. Then the force at J is 1 kilonewton, so this is a very long one. 1 times 5 times, there are 5 of the panels. Then the very last one, what we are solving is this reaction support at L, and that has 6 panels times 5, and then that's make it counterclockwise. It's plus that equal to 0. Okay. So when we have all those, and we can simplify it, of course, we're going to divide by 5 on every single term. When we do that, hopefully will help make it a little bit simpler. So we have -5. The second is -5 times 2. I'm just going to write down the answers now. The third one is going to be 15. Then this one will be just -1. Next will be -2. This will be -3, -4, -5, plus 6L. That equal to 0. Then go ahead and we'll solve them all, right? So that together is going to be -30. Now let's see all those together. 3, 6, 10, -15. So we'll have -45 plus 6L equal to 0, right? Then we'll have our value for L. So I have 45 divided by 6. So L is 7.5 kilonewton. I surely hope this is correct because my second step is dependent on the correct answer. Alright, so that's going to be L. Now we're going to go to our step 2, which is our FBD number 2. FBD number 2, remember we said we're going to just cut over here, and we're going to look at the right section. So first of all, I'm going to draw those section that's not being cut. They're intact. Make that shorter. Okay, so what do we have here? We'll have our L, our K, and J, and our I, and H, right? So, and then this short length here, that's extended to F, and short length here, that's going to be extended to G. Also, don't forget, I almost did, it's going to be, we cut GH also, that's going to extend to G diagonally. So that's going to be the section we have. Now we're going to draw all the forces on it. We had to figure out the reaction at L is 7.5 kilonewton. And also there is external force at H. At J, they both are 1 kilonewton each. Then when you cut it, those three members, they are going to have three unknowns. Then we're going to we'll assume this is a direction. We're going to call this FH. We're going to call this GH. For this, we can go this direction. We're going to call GI. Okay, so those are the three unknowns, and let's see how do we solve it. So forces at, instead of do forces, how about we start with moment? If we do moment at G, what can we solve? We can solve FH right away, right? We can indeed solve FH because GH and AGI goes through point G. So in that situation, we have 7.5 right here. And we're rotating about G here. So what's the moment of arm? So it will be this length. And that will be 3 panels. That's going to go in clockwise rotation, so that's plus. Then we have this 1 kilonewton. This 1 kilonewton is applied at J, and so the moment of arm will be this length right there. That's going to be 2 panels. And that's clockwise rotation, so it's negative. Then we are looking at this 1 kilonewton at H. And then the moment of arm will be just 1 panel of 5 and clockwise, so that's negative. The only other force is FH. So our FH is in an angle, and we're rotating about G, and we needed to decompose it first, right? So if I were to decompose this force FH, that's going to be my y component and x component. And we need to know the angle or the geometry. Now let's take a look. If I were looking at the half of the truss, this is 3 panels here down, so that'd be 15. And this is 8, right? So then what's going to be our hypotenuse? 15 squared plus 8 squared. And then take a square root, happen to be 17. So this is 8, 15, 17 triangle. Then I can go ahead and to label that on my FH here. My FH here is going to be 8 is vertical, 15 horizontal, 17 is our hypotenuse, 8, 15, 17. Then we can go ahead to decompose, right? But here we're in a moment equation. We have to find out the moment of arm. The moment of arm, we have to know where this forces is applied at. Here we said it's going to be start on here. Again, remember when you make a cut, it's arbitrary. You can cut somewhere here or here as long as in between FH, GH, and GI. So in that situation, you kind of safely can conclude that I can actually consider my force is applied at at H right here. Or you can say it's applied at this F right here. You have to choose one, right? If I can tell you, regardless you choose the force is applied at H or G or F here, your answer is going to be the same. Here, let's just assume we applied at H. That helped us. So we're going to decompose. Again, I have over here. That's better than it's applied at H. So our X component, which will be 15, 17, FH. And now what's the moment of arm? The moment of arm will be just this distance right there. And which will be... Okay, so the distance will be here, that distance, right? Then I start to regret. I shouldn't take applied at H. Why? If I decided to apply at F, then I know this length is H. I can go ahead and solve this length, HI, using proportionality. We can, but I want to use the easy route. So in that situation, I'm going to make a note. Oh boy. All right, so what do? Is I'm going to I think inevitable I have to just go ahead and draw it better. But it's good that you know the thought process I have over here. So it's that, right? So that's our I, and that's our K, L, J, H. And right here, we're getting like that and that. That's our G. And we assume this force here is going GI that direction. And this will be our GH. And our FH, the way we're giving it, we consider is going to be applied here, even though it's, 30. So that's going to be our FH. And that's our point F. Okay. Why I have to be very specified where by point of application? As you can see, we are working on the moment equation. We have to know that in order to find our moment of arm. Okay, so that's our, if that's a situation, we can decompose to X and Y component. This is 8, 15, 17. All right, 15, 17 go back to FH and X component, and our moment of arm will be exactly this length right here, which is 8 foot. And that's going to be counterclockwise, so it's positive. Now let's look at Y component. Y component is going to be 8, 17, FH. And we're rotating about G, and the Y component happens to be going through point G. right? So in that situation, it's times 0. And I really start to like the way we are deciding to make the point application at F here. So that's equal to 0, all of that. Let's go ahead and solve it. So we have 15 times 7.5. 112.5 minus 10 minus 5. All right, so we'll have 15, 17 times 8 FH. That's going to give us answer of negative 97.5. Then we're going to times 17, then divide by 15, then divide by 8. Then we'll have an answer for that as FH as negative 13.8125. I'm dying to see my answer. All right, I think we are good. So we got FH to be that answer. Excellent. Okay, and it's negative value. That means the true direction on FH is not going to be, it's going to be this direction, right? The true direction is that. So which means it's pushing in. So that tells us it's a compression. FH is a compression here. Okay, so now we know you have found FH. How do we find the remainder force, which is GH and GI here? Now we can go ahead using forces at X direction. If we have forces at X direction, what do we have here? By the way, I need to continue to copy my FBD here, 7.5 kilonewton and a 1 here on both of them, right? Now, forces at the X direction, what do we have? We have GI pointing to the right, and GH, what we're solving here. GH, we needed to know the geometry in terms of the angle. So how do I figure it out? This is our GH. G is here, H is here. So let's go ahead and solve that. Then here, kind of inevitably, we're going to use proportionality. So what we're going to do is we're going to look at this big triangle compared to this small triangle here, right? Then base over height, right? So in that situation, we want to figure out, this is I. HI, we do not know the length. HI over this length, which is 8, base over base, and the height, this is 2 of the panels, and over this base, it's 3. So in that situation, you can find the HI is going to be 16 over 3. Okay, so knowing that, we can go looking at this GHI triangle. HI is 16, 13, right? Then our GI is 5. Then you can go ahead and figure out the GH here using Pythagorean theorem. Once you know that, then you know the slanted in terms of this GH here. We know this is 5, this is 16 over 13, and you can figure out the hypotenuse here. So here, I think the rest is just some tedious calculation. You can go ahead and solve the rest for fx direction equations and fy. Then you can go ahead and solve your GH and GI, right? Okay, that's all for this video. I'll see you next time. Bye.